Doing problem 3, section 4.3. Part A I have got written up here already. Let's just use our general power rule or chain rule to take the derivative here. Remember that the general power rule says we take the exponent, put it in front, leave the inner function alone, lower that power by 1, and then we take the derivative of the inner function and multiply. So we get 6x squared plus 9. So there's our derivative of that one. Part B, f of t is equal to, now this is a square root. I'm going to go ahead and write that square root as a fractional power. That's really the way that you always want to deal with roots. Write them as powers, and then you can use that general power rule on them. So a square root is a 1/2 power. We're calling the function f of t, so I'm going to use a little bit different notation here for the derivative. F prime of t, again, general power rule, we put that 1/2 in front, multiply it by the 8. It's going to give us 4. Leave the inner function alone. Lower the power by 1. That's going to give us negative 1/2, and then multiply by the derivative of the stuff that's on the inside of the parentheses. That's 8t. Okay, this one we can simplify a little bit. The 8 and the 4 are going to give us 32, so we'll get 32t, and then that's a negative exponent, so we can move that to the denominator, 4t squared plus 7, and you can then write it as a positive 1/2 power or as a square root. So that one for part C. Looks like we've got a product rule there, so p of z is equal to z times 6z plus 1, and 4/3 power. So this one's going to require a product rule. See if I can squeeze that in here. So p prime of z is what we want here. So product rule, take the derivative of the first, that's just 1, multiply by the second, that's going to give us 6z plus 1 to the 4/3 power. Then plus the first function, which is z, times the derivative of the second function, which is going to then require the chain rule. So the chain rule says that one, we put the 4/3 in front, we leave the inner function alone, so the 6z plus 1 stays as it is. Lower the power by 1, that's going to give us a 1/3 power, and then we multiply by the derivative of the thing on the inside, that's 6. You can simplify this one a little bit as well. We'll write this as, the first part will just stay the same, 6z plus 1, 4/3 power, and then this one, multiply the 6 and the 4/3. 6 divided by 3 is 2 times 4 gives us 8, so we're going to get a plus 8z, and then the rest of it just stays as is, 6z plus 1, the 1/3 power. So there we go for that one. The last one is going to require a quotient rule. Let's see if I can fit it on here. I might have to write a little bit smaller on this one. So y is equal to 3x squared minus x divided by 2x minus 1 squared. Let's see if I can get a better, less squeaky marker here. Okay, so quotient rule, dy dx. So remember, the quotient rule says low d high, so the low function 2x minus 1 times the derivative of the top function, that's 6x minus 1. And then this is minus the top function, high, d low, so this is going to be 3x squared minus x. And then the derivative of the bottom function is going to require the, try to separate these a little bit. The derivative of the bottom function is going to require the chain rule, so we're going to have put the 2 in front, leave the inner function alone, lower the power by 1, that's the first power, then multiply by the derivative of the inner function, which is 2. All this gets divided by the bottom function squared, 2x minus 1. You square a second power, you get a 4th power, so that's what we get. Now on this one, what we can notice here is that to simplify this, this is a bit of heavy algebra here. We've got a 2x minus 1 here, and we've got two of them here, okay? So what we can do is actually factor that 2x minus 1 out of this thing. make sure we're getting room here. If I factor out that 2x minus 1, one of them, then what am I left with? Well, I had two of them there, so I'm still going to have one of them. So I'll get 2x minus 1 there. And then this 6x minus 1 stays. Then this is minus, and I factored that out, so it's gone. So what am I left with? The 2 times 2, and then that. So I'm going to have minus 4 times the 3x squared minus x. Okay, and then all of this gets divided by the 2x minus 1 to the 4th power. And the reason that we wanted to factor that out is because we notice now it's the same as what we have in the denominator. So we can cancel, and that's going to become a 3rd power. Stuff that's left in the numerator, you can go ahead and try to expand that if you want to. I would say that at this point it's okay that we just leave it as it is. So I'm just going to leave this as 2x minus 1 times 6x minus 1. If you did happen to expand this, you would find that you're going to get some like terms. Like this first one here is going to give us a 2nd power. You're going to have a 2nd power here as well. So it might be beneficial to actually go ahead and simplify this if you want to do that on your own. But really, for the purposes of what we're going to do in the future, we definitely will want to actually go ahead and simplify this when we work on this in future problems. If I distribute that minus 4 there, I'm going to get a plus 4x. Oops, and that's the 2nd power there. And then this is all divided by the 2x minus 1 to the 3rd power. So this could be more fully simplified. For one, I'm out of room at this point, but if you wanted to simplify that numerator, just use FOIL on that, see what like terms you have, and simplify that as much as you can. Okay, a lot of writing on this one.